we are going to find average rate of change. So in algebra, in math, average rate of change is going to be modeled by slope. So we have this slope formula right here. So y sub 2 minus y sub 1 equals x sub 2 minus x sub 1, which means we have two coordinates, xy coordinates, which would normally be something like this, x1, y1, and x2, y2. So we just have two coordinates. This is the first one I wrote down. This is the second one I wrote down. So we use 1s and 2s. And then we can find the slope of the line from there using this formula. So what we're going to do is look at intervals. So we're given two x coordinates, which means we're going to have to find corresponding y coordinates. So that's what I'm going to do first. Once we have our 2 points, we are then going to go through and find slope. So the first one says I have g of 2 equals 3 times 2 plus 4, which is going to be 6 plus 4, which is going to be 10. So I know that my first point is 210. I evaluated at 2, I got a 10, so my point is 210. The second point I have is going to be g of 4, so I have 3 times 4 plus 4 is 12 plus 4, which is 16. So my next point is going to be 4, comma 16. And now I have x1, y1, x2, y2, so I can find slope from there. So if this is the first point I wrote down, it doesn't matter which point you write down first, the signs will work themselves out. So I have, first of all, y sub 2 minus y sub 1 over x sub 2 minus x sub 1 gives me a y sub 2 of 16 minus a y sub 1 of 10 over an x sub 2 of 4 minus an x sub 1 of 2. So 16 minus 10 is 6, 4 minus 2 is 2, and 6 over 2 gives me an average rate of change of 3. Now, bonus points for imaginary candy. Your original function was a linear function with a slope of 3. And you just found out that the slope was 3. So, good job. Let's move on. So we have g of x is going to be, this is option B, 3x plus 4. And you're thinking, oh, I'm not going to fall for your little trick again. But it's not a trick this time, because this time we're dealing with variables. So I'm going to start with an x value of 2, and then I'm going to add a little bit to it. So 2 plus a little bit more. So 2 plus h, whatever h is, I don't know. So we're going to be dealing with a formula here, so it's not going to be just a solid constant for an answer. It's going to be a formula for slope that if we knew what h was, we could figure out what the rest of it would be. So I'm going to figure out what g of 2 is, which I already did, but for consistency, we're just going to go through and figure it out again. So I find out that g of 2 gives me a 10, just like I found it up here. Well, now we're going to evaluate at 2 plus h. So I have g of 2 plus h will give me a 3 times a 2 plus h plus 4. So I'm going to distribute. That gives me a 6 plus a 3h plus 4. I'm going to combine like terms, which gives me 10 plus 3h. Okay, so we have our 2 points. Our 2 points are 2, 10, and then 2 plus h, comma, 10 plus 3h. So if I gave you a value for h, you would be able to figure out what this was. So if I said that h is 10, then this is going to be 12, and this is going to be 40. Okay, so we're just giving you a formula. So this is x2 and y2. So now my formula for slope is going to be y2 minus y1 over x2 minus x1. And that gives me a y2 of 10 plus 3h minus a y1 of 10 over an x2 of 2 plus h minus an x1 of 2. And now, did I need the parentheses? I only put them in there because I had multiple terms in my second point. And so I really don't need those parentheses. And because I'm running out of room, I'm just going to say ignore the parentheses. So I have 10 minus 10 is nothing. And so that leaves me with a 3h on top. And then I have a 2 minus 2 gives me just an h on the bottom. Well, then any number divided by itself is 1. So ha ha ha, you end up with a slope of 3 again. So bottom line is this is a linear equation. It doesn't matter what you evaluate at, your slope is 3 all day long. Okay, but you still have to learn how to do the substitution and stuff. So moving on, this is going to be foundational for calculus. It's called the difference quotient in calculus, and we're just doing a small part of it right now. So moving on, let's try another one. We have h of x is 4x squared minus 7. And we're going to do this on the interval of 3 to 5. So first of all, notice this is no longer linear. Your slope is not 4. So don't fall into that little trap right there. This is a parabola. And so I can't just say, oh, my slope is 4. You know, she tried to trick me. No, I didn't. This is a parabola. We're going to find average rate of change over this interval on our parabola. So I'm going to use 2 points. So my first one is h of 3 will give me a 4 times 3 squared minus 7, which gives me 4 times 9 minus 7, which gives me 36 minus 7, which gives me 29. Okay. The second point is going to be h of 5. So we are on the interval from 3 to 5. So I have a 4 times a 5 squared minus 7 is 4 times 25 minus 7 is 100 minus 7 is 93. So we now have our 2 points. So we're estimating here. We're not going to find the perfect amount for slope or the perfect value for slope, but we're going to estimate on this interval. So my point at 3 produced a 29. So that's the first point I wrote. And then my second point was 5, which produced a 93. So I have x2, y2. And now I can go straight on back in and find my formula, which is y2 minus y1 over x2 minus x1. So I've got 93 minus 29 over 5 minus 3. So 93 minus 30 is going to be 63, but that's one too many, so that's 64 over 2, which gives me 32. So my slope on this interval, on this parabola, is going to be 32. Okay? So, and that's just for the line connecting those 2 points. So we now have, that was, what was that? That was C. I forgot to label it. That was C. Here is D. So we now have h of x. So we're going to make it a little bit more intense. We're going to use the exact same formula, but we're going to leave it, I don't know what I just said. We're going to use the exact same formula as what we had up here, but instead of using perfect numbers, we're going to use variables again. So I've got a 3, so I'm starting with the x value of 3, and then start at 3 and add on a little bit more. Okay, so this is an x value of 3 and 3 plus some more. So same process. I'm going to evaluate at 3 first, which we've already done, but we're going to do it again for consistency. So I've got 4 times 9 minus 7. I've got 36 minus 7, and that gives me 29. So my point is 3, 29, which we already had from up here. Now this one's a little bit different. So we have h of 3 plus h. So that gives me 4 times 3 plus h squared minus 7. And now I'm going to have to FOIL this out. So I'm going to do this on the side over here. I have a 3 plus h times a 3 plus h. which gives me 9 plus 3h plus 3h plus h squared. So when I FOIL this out, I'm going to run out of room. I'm going to end up with 4 times 9 plus 6 h's plus h squared minus 7. And that gives me 36 plus 24h plus 4h squared minus 7. So I can combine my 36 and my negative 7 together to give me 24h plus 4h squared plus 29. So my other point that I was just given is a 3 plus h, comma, and then I'm going to put this in descending order. 4h squared plus 24h plus 29. So again, if I tell you what h is, then you'd be able to tell me the corresponding point. So now we're going to put this into slope. So y2 minus y1 over x2 minus x1. So my y2 is this nasty thing over here. So this is x1, y1, x2, y2. So my y2 is this polynomial right here. So he is a 4h squared plus 24h plus 29 minus my y1 is 29 over my x squared is 3 plus h minus my x1 is 3. Okay, so I'm going to combine like terms. My 29s are going to go away. So 29 minus 29 is no 29s. So I now have a 4h squared plus 24h over my 3's drop off, and I'm left with just h. So 3 minus 3 is 0, so I'm left with h. And then everything is reducible by an h. So what you're technically doing is you're factoring out an h from your numerator. So that's going to leave you with a 4h plus 24 over h, and those h's reduce, which means your formula for slope, or your average rate of change, is 4h plus 24. So again, if I told you what h was, you would be able to tell me what the slope was at the point 3 comma 3 plus whatever h you told me was. So the last example that we're going to do is going to be all variables. So I have f of x equals 2x squared minus 3x. What? 3x. And I'm going to be on the interval from x to x plus h. So this time I don't have any variables whatsoever. I mean, any constants whatsoever. All I have is variables, which means I'm going to return a formula to you when we find the average rate of change. So first of all, we're going to evaluate. Well, I already know what f of x is. So just like on the previous examples, I took my first point and I substituted in x. Well, that part's done. Okay, so I'm just going to write in and say, well, f of x is, and I get 2x squared minus 3x. Okay, so that part's done. This part is going to require some work. So I've got f of x plus h is going to be 2 times x plus h squared minus 3 times x plus h. So this was a 2x squared minus 3x, but I trashed my x's and put in x plus h's. And so now I got to FOIL this thing out. So I'm going to come over to the side again. I've got x plus h times x plus h, which is going to give me x squared plus xh plus xh plus h squared. So when I rewrite this, I'll have 2 times combining like terms gives me x squared, 2xh, and h squared minus 3x minus, piece of trash, 3h. Remember, when you distribute, that negative 3 belongs to the x and that negative 3 belongs to the h. So this says negative 3x minus 3h. Now we distribute this too. I'm going to give myself a little bit more room to write. So I have 2x squared plus 4xh plus 2h squared minus 3x minus 3h. So that is what this looks like, what this formula looks like when you substitute in an x plus h. This is what it turns into. So now we're going to find the slope. So m is y2 minus y1 over x2 minus x1. So what do we know? We know that if I substitute an x, I get an f of x in response, correct? Okay, so what we have then is if I put in an x, what did I get for an answer? I got 2x squared minus 3x. So this is my x1, y1. If I evaluated x, this is what I get for an answer. If I evaluate at x plus h, this is what I get for an answer. So 2x squared, 4xh, 2h squared minus 3x minus 3h. Okay, so that is my x2. This is my y2. So it's kind of messy. I shoved in an x, I got this for an answer. I shoved in an x plus h, I got this. Okay, so y2, and I'm going to learn my lesson and give myself plenty of room to write, is going to be 2x squared plus 4xh plus 2h squared minus 3x minus 3h. That's your y2. Okay? Minus, what's your y1? 2x squared minus 3x. All over my x sub 2 is x plus h. My x sub 1 is x. Okay, so I'm going to distribute this negative, and then we're going to see what we have that matches. So I've got a 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2x squared plus 3x all over x plus h minus x. Okay, so what is going to cancel out? Well, I noticed that in my denominator, the x's are gone. I notice in my numerator, I've got a 2x squared minus a 2x squared, and a positive 3x and a negative 3x. So everything else simplifies down to a 4xh plus 2h squared minus 3h over h. But notice that everything has h's. So I'm going to factor out an h from the top, which leaves me with a 4x plus 2h minus 3 over this h, and I end up with this as my formula for what would the slope be. Okay, so I would need to know x's and h's, but at least I have a formula for what the slope between 2 points would be.